Okay, so in example 1, I come to this negative sign first. That tells me that there's a reflect in the x-axis. This plus 3 here, that tells me that it is a translate. Oh, I skipped something. Translate left 3 units. And what's the 4 tell me? Up 4 units. And then this 2 in front tells me something else. Vertical stretch. Factor of 2. So I have my parent function points. Because if it's vertex form, that is the transformation form. That's the form where we can find all of our transformations and easily move everything around.
So we're going to multiply the 2 on the y?
Y. That is correct, but y? So then we apply all of our transformations. So I used my parent function points, and the 2 and the negative sign are both vertical. So both of those are going to be on the y side, multiply by negative 2. And the translate left, that is on the x side. Since I'm going to the left, I write subtract 3. The words and the table match each other. The words in the table are the same. It's the equation that's opposite. But the words in the table are the same. And then after I do this...
Teachers, we are still on lockdown. Please make sure that no students are in the hallway. Thank you.
Okay.
Does that mean we need to put that thing?
No. That's for Alice. That's not for lockdown. Okay. And then the translate up 4 units, I also have to put a plus 4 on the vertical side. Now, why do I have the times by negative 2, then the plus 4? Can I have them in the other order?
Sure.
I can? I can't? Why? I have to do order of operations, which says multiply before add, so they are in order. Okay. So now I'll go ahead and fill up my table. Okay, and it does not take me...
Why are you timesing it by negative 2?
Instead of... Why am I times it by negative 2 instead of doing what?
I don't know why.
Or why am I multiplying by negative 2 at all?
No. On
Okay.
the y side
Yeah.
of the table, why are you timesing it by negative 2?
Because reflect in the y or in the x-axis and vertical stretch factor of 2 mean multiply by negative 2, and since those are both on the outside of the squared, they go to the y values. Okay? So once you have rewritten all of your points, you can say bye to the 3 inner columns because those were just work. It's the outside x and the outside y. Here's the division between x and y. It's the outside x and the outside y that you graph. So negative 6, negative 14, not going to fit on my graph. Negative 5, negative 4. Negative 4, 2. Negative 3, 4. Oops, I did this one in the wrong spot. Negative 2, 2, negative 1, negative 4. And then 0, negative 14 is off the graph. This is what we have been doing. But see how I'm still reviewing, because I want everybody to be able to do it. Oh, before I change the page, let's find the vertex and the axis symmetry. The vertex and the axis of symmetry. Where is the vertex on this new graph? -3, 4. Could we have gotten the vertex from just the equation without even graphing it? Yes, because the formula right here for vertex form says we always subtract the h part and add the k part, and hk is the vertex. So you do the opposite of the x and you do the same y for your vertex. So here I could have done +4 for my vertex. How about the axis of symmetry?
X equals
After lockdown is still in place, no one should leave any rooms at this point for any reason. That's a medical emergency. Please call on the office of medical emergency. Thank you.
Apparently people are walking through the hall, which is why they have to keep coming on there. Okay, so the axis of symmetry, x equals -3. And you guys seem like you knew that one. How did we know that one so well? It's in the middle. I know what you're saying. What else? Rachel? Say again, Rachel. You go the x value of the vertex, and it's always x. Okay. 2 more. Prove that you can do them. 2 more. Prove that you can do them. 2 more. Prove it. Daniel, do them.
Y'all see, you have a negative outside of this.
You have a negative outside.
But then you have a positive, whatever, outside at the end. But that negative turned that positive to the negative.
Not if this like if there was a +2 here,
Yeah.
that would not make this negative unless we had another set of parentheses, which we don't. So unless we had another set of parentheses, it would not.
The things separate.
Yeah. Okay, so for this one, I got my vertex at -1, 0. My axis symmetry is x equals -1. Over here, excuse me, coughing. For this one, we had a vertical stretch factor. Applied all my y's by 2. Inside, I have a translate to the right 2 units. So I added all my x's. I added 2 to all my x's. And then at the end, I have a translate up 5 units. So I took my y's. I took the previous y's, and I added 5 to those. And that's where we got the new graph. And that's how I got my vertex at 2, 5, and my axis symmetry at x equals 2. Question?
So, it's like everything to the left of the, no, to the right of the x, y, and then the left of the x.
Where are you looking? In the equation or the table? So this separates the x and the y.
Yeah, like both like from the table and like in the equation.
So everything this way is horizontal, because anything to do with the x is horizontal. So we do it all to the x. Anything this way is vertical. right? Because everything with the y is vertical. Okay? All right, so what I have here is something that is in your curriculum that you're supposed to do with me. This says we are going to derive standard form by expanding vertex form. So we're going to derive standard form by expanding vertex form. You'll never have to do this on your own. We're going to do it together. So what does it mean to expand? Okay, that means instead of a squared, what do you think I'm going to have? We did this last class. Instead of a squared, or maybe it's 2 classes ago. It was Monday. Instead of a squared, what do you think I should do?
Write it like in parentheses x minus h and then times it by itself again.
Perfect.
This ends the lockdown. Students and staff, thank you for your cooperation. Have a fabulous afternoon. As always, go Five.
Okay. So I expand it by writing x minus h times x minus h. Now we are going to multiply those together. So you can either use the FOIL method or you can use the box method. Whatever method you want to use. It's the exact same work. What is it? X minus h and x minus h. So if I multiply those, I get x times x. What is x multiplied by x? X to the second power. That is the definition of what x times x is. Now for this triangle, no, square or rectangle, I'm doing x times negative h, which is negative xh. Okay. And in this one right here, I'm going to do negative h times, nope, I lied, x, which is negative xh. And then this one right here, I have negative h times negative h. So negative times negative is positive, and h times h is h squared. So from there, I have to combine like terms, which are the middle 2 terms. I've got x squared. I have minus 2 xh's. And then I have plus h squared. And then I have my, outside of that, I have an a, and we have a plus k over here. Yes?
When you multiply like x times negative h, does it matter like the order? Like if you get
No, I went off what people said. I probably would have written hx if people were. But it means the same thing either way. I just normally write alphabetical order. So either way is fine. Okay? And then from here, we're going to distribute. That's going to be our next step. We're going to distribute that a. So I get ax squared minus, let's reorder it, 2ahx plus ah squared plus k. Yes.
squared ones next to each other? Like if we were
Wait, did we distribute?
I just distributed the a.
okay,
That's what I was doing. I was distributing the a.
My bad.
Dylan. Wait a moment, please. From here, we're going to talk about standard form. And standard form is written right up here. I'm going to write that exactly underneath this, and we're going to compare them. So we're going to write standard form right here. Standard form is little a x squared plus bx plus c. So these two expressions are equivalent. It's just h and k we don't have in standard form. So this one right here is standard form.
My friend is teaching us.
Teaching you this?
Yeah.
Okay, so what I'm going to do is just color code a couple things. What is something that both equations definitely have in common? They both have ax squared. So I'm going to stop and say they both have the x squared, okay? They both have the x squared, and they both have the a. Let's highlight that. So in vertex form, A stands for, in vertex form, A is the either reflect in the x-axis, or it is a vertical stretch or shrink. And then in standard form, it's exactly the same, like A hasn't changed. It's still there, and it's next to the x squared. Like A is exactly the same in vertex form as it is in standard form. They have the exact same meaning. So if A was a negative in vertex form, what would that tell me to do? Tell me to reflect it. If A is a negative in standard form, it tells me the same thing. There's a reflection. So the A's are exactly the same thing. What else is exactly the same thing? There's no C in this form. The X is the only thing else that's the same. But we can compare things together. We can say that whatever B is in standard form, in vertex form, it's the same thing as negative 2H. They are the same. These things are the exact same things. And in standard form, whatever C is, that's the exact same thing that in vertex form would be AH squared plus K. So down below, we're going to fill in blanks that say what I just said. So A equals what in the, it equals A. A equals A. Those are the same. But B is the same. The B is what? Now this says solve for H to obtain what H equals. Okay, let's solve this equation for H. What do we do to both sides to get H by itself? No, you were right. You were right. So if I divide both sides by negative 2A, I get H equals negative B divided by 2A. It is. This shows you how this formula came to be. That just tells you how we got the formula. This is the axis of symmetry. The axis of symmetry is x equals negative b over 2a. Because the axis of symmetry before was whatever h was in vertex form, so now it's negative b over 2a. Okay, same thing with C. C equals, we had a big thing for C. C equals AH squared plus K. In vertex form, if I did f of 0, that means if I put in 0 for the x, I will get I'll get negative h squared plus k, and then what happens when I square negative h? It turns AH squared plus k. So if I plug in 0, that's what I get. That's the exact same thing is C, which if I plug in 0, that is, does anybody know what that is? If I plug in 0 for x?
So the negative h turns to positive h squared because you're squaring it?
Yeah.
Okay.
Yes. What am I finding if I plug in 0 for h? No, sorry, you just said h. If I plug in 0 for x in the equation, if I plug in 0 for x, what is that on a graph? If x is 0. Oops, just kidding. If x is 0, that could be anywhere here. What is that on the parabola? It's the y-intercept. C is the y-intercept. So what we did was we took vertex form and we multiplied it out. That changed it into standard form. And then I just went through why we have formulas of what we have. You need to know the formulas. You won't have to actually derive the formula ever again. You just need to know the formula. But for those of us that need to understand why, because you're going to go on to higher level math, so this stuff is written on the next page as well. So this is the concept we're doing today. One of the concepts we're doing today.
So, I was just doing notes while we were on. So for these, we just make an equation.
And that's on the video we did. Okay. All right, so we've got properties of the graph when it's in standard form. So let's make sure that everybody has in their notes that this is standard form.
But we just went over it.
We did. This is just a summary. So this is summary of everything for standard form. Standard form is ax squared plus bx plus c. Here, if the a value is positive, it's going to open up. The axis of symmetry will be x equals negative b over 2a. This is the y-axis. I got confused for a second. The y-intercept would be 0, and then whatever the c value is, whatever that c value is. Okay, over here, this would be when x is less than 0, so it's going to open down. We still have x equals negative b over 2a for our axis of symmetry, and our y-intercept is still 0c. Okay, it's just the a value changes it if it's up or down. So the parabola opens up when a is greater than 0, opens down when a is less than 0. We still have stretches and shrinks. If the a value is greater than 1, it's going to be a vertical stretch. If the a value is between 0 and 1, then it's going to be a vertical shrink. That's what this talks about here, being narrower or wider. The axis of symmetry is x equals negative b over 2a. To get the vertex, which we'll do in a moment, to get the vertex, you put the axis of symmetry in the x part of the ordered pair.
So OC is y-intercept?
0c, yes, but I'm not on that one yet. I'm right here. So you plug in this for x. And when you plug that into the equation, you get f of x. You get the y value. This here is the output, and that becomes the y value for the vertex. This is the vertex. And then the y-intercept is 0c. So we're going to do that with this equation.
Wait, I didn't see the other. Pull it up and keep it open.
So when you are given standard form, the first thing you want to do is just recognize its standard form, which is the form of ax squared plus bx plus c. That's the first thing I'm going to do. Then I'm going to find my axis of symmetry. I'm going to start with my axis of symmetry. And because some of you don't know this formula, you should write. The axis of symmetry formula is x equals negative b over 2a. So let's take that formula and plug in the numbers. So x equals negative, what is my b value?
6. Negative 6.
It's a negative 6. It will become positive. Over 2, and then what is my a value? 3. So there's me plugging everything in. And then I will get positive 6 over 6. So I'll get 1. My axis of symmetry is x equals 1. So I can go to my graph, and at x equals 1, this is the axis of symmetry. It's not really part of the graph, which is why I'm dashing it. It's just a reflection line. Excuse me. New? Did you ask if it's new?
Yeah.
We haven't covered this year at all. So this is new for us. This is new for us. But I know you've covered it before because Avneet said it the other day, so I know she's heard of it before. Avneet had Algebra 1 last year. Right. She's a sophomore, so that's why she remembers it more than some of us. Okay. Hey, you're being recorded, so.
Hi,
Mom. All right, so now the vertex. I haven't showed you how to do the vertex yet. It says up here, but that to me looks really confusing. I'm going to go over that. So the vertex, what do we know about the axis of symmetry and the vertex?
Oh, the X.
The x is the same. So what we do is we take that x and we do f of that x. That means wherever I see an x in the equation, replace it with parentheses 1. So 3 parenthesis 1 close parenthesis squared minus 6 parenthesis 1 plus 1. Plug in 1 for the x. That comes from the axis of symmetry. Boink. So now I do 3 times 1 squared, which is 1, minus 6 plus 1. So 3 minus 6 plus 1. Negative 3 plus 1. Negative 2. So my vertex is my axis of symmetry 1, comma, the output I just got, negative 2. 1, negative 2, put a dot. Now, when you graph these, that you find a minimum of 5 points so that your parabolas don't look terrible. How many points do I have? I need some more. So I would always suggest y-intercept, and it does say, you know, how to find the y-intercept. I always suggest the y-intercept because it's really easy in this form. For the y-intercept, you plug in 0 for x. So it's like 3 times 0 squared minus 6 times 0 plus 1, which, if you paid attention to the formula above, plug in 0, it's the c value, 1. But, like, even if you don't remember 0c, like, I still got it by plugging in 0. So my y-intercept is at 0, 1. So now I have 2 points. What does this line do? It's a reflection. So I should be able to find 3 points by reflecting my y-intercept over this line, and look, I now have 3 points. So that's all I got from this information.
Wait, excuse me?
I need 5 points minimum, and I only have 3. So you can plug in any other number you want. Well, that's going to fit on the graph. What number would make sense and would be easy for me to plug in right now? 2's already plugged in. Look, 2 is 1.
So you go up 3, you go up 3, and then you go up 5.
No, that's only if there's no stretch. There's a stretch on this one. And it's not in transformation form. I'm sorry, what were you guys saying, plug in?
3.
There's not a wrong answer. I think 3 is a good one to plug in because it's close to that. I also think negative 1 is good to plug in, except it's negative, and sometimes people make mistakes with negatives. So you know you. We'll plug in 3, but you know you. If you feel like you could plug in negative 1, that's fine. But we'll find extra point. Find extra point here. Extra point. I'm going to plug in, what did I say, 3. I'm going to do f of 3. That's how I show what I'm plugging in, f of 3. So that means I'm going to have 3 parenthesis 3 squared minus 6 times 3 plus 1. So I'm going to have 27 minus 18 plus 1. 9 minus plus 1, 10. So my ordered pair is going to be 3, 10. Did anybody try negative 1? Anybody try it? Or you all did what I did? Just curious. So I can go ahead and graph 3, 10. And I'm glad that I picked 3 and not 4, because what would have happened if I had picked 4? It would have been way off the graph. So it's a good thing I picked 3. That's 4 points. I plugged it into the equation. I just plugged in the equation. Oh, how did I pick 3?
Yeah.
Because it was like, I knew when x is 0, I knew x is 1, I knew when x is 2, but I didn't know where x was at 3, so I just plugged in 3. I'm just trying to keep it close to these points. So I just picked a point.
Can you take that email?
No.
I can never see the column.
Sorry. Get a watch. You can bring me your planner too, son. Okay, so from here, how many points do we have? Is it 5? Is it 5? 5th point. How? Jessica? Reflect this 4th one. It's 2 away, so it's going to be 2 away. And we have 5 points now. So I say minimum of 5 points. That means you can have more if you need it, but minimal 5 points. Okay, I'm going to skip 3. We'll just go to number 4 because of time. So this is the exact same thing again. Just more practice, exact same thing again. We look at this and we see this is standard form. P of x.
This is too much.
Are you one of the teachers that gives XC?
Yeah, when we get through this first part.
Cool. Let's do it.
So I write ax squared plus bx plus c. Now we're going to do the axis of symmetry.
Wait, would it be minus bx or?
No, this is the formula always, but the b value will be negative 8.
Wouldn't it be positive?
I have not, you are ahead of me.
Oh, sorry.
Okay, so then we do the axis of symmetry, and I'm going to write down the formula every time I do it so that I can memorize it. X equals
Negative b divided by 2a.
negative b.
I memorized, so.
So now we're going to plug that in. X equals, we'll do negative, and then yes, I'll have a negative 8 over 2 times a is negative 2. Oh, before I graph anything, what does the fact that a being negative tell me? It's going to be facing this way when I'm done. So if it doesn't face that way, I know I've done something wrong. Okay, so now I simplify this. What does that become? 8 over negative 4. So x equals negative 2. That is my axis of symmetry. So I went and graphed at x equals negative 2. The vertex comes next. The vertex, we use our axis of symmetry.
Can you put a dot at negative 2, 0?
No, because we have to put a dot where the vertex is, and I haven't plugged it in yet to find. So I have to plug in negative 2 into the equation. So I show that by doing p of negative 2. Remember, I've been working on this function notation with you, because you'll see it a lot. That means replace all of the x's with negative 2. So every place I see an x, I put a negative 2. So you got negative 2 squared here, and I've got a negative 2 there.
Okay, so then you just plug in the x. Axis of symmetry.
Let's say A over S.
I don't feel like saying.
So after I plug in negative 2 and I simplify it and I do some quick arithmetic, I get 9. So negative 2, 9 is the vertex.
What?
negative 2, 9 is the vertex.
So then, should we put in the -1? Say
Hold on, what are your questions?
Oh, my bad.
-2 times -2
Is positive 4
is +4.
times by negative 2.
Did you?
4 squared.
No. Negative 2 squared
Oh!
is 4.
Yes.
Were you multiplying these two together?
Yeah.
Is that what you were saying? There was too many negative 2's. So you have to square first, then multiply.
So then multiply by 2. So it'd be -8. Okay.
Okay. So I graphed my vertex from here. Let's find our y-intercept. What is our y-intercept? Plug in 0, what do we get? 1, it's the c value. Boom. 0, 1, y-intercept.
So, okay, so
And I'm going to use that reflection, which is 2 away, to find the other point there.
wait. Vertex, you just took that axis of symmetry.
And plugged it in.
For X.
That's exactly what it is.
Alright,
Okay, so now what we're going to do is find one more point, which hopefully will give us 2 more points because we need a total of 5 points. What number should I plug in?
2.
Okay. Out of all those choices, I feel like 1 sounded the easiest to plug in. But you can plug in 2 if you want, but it's probably going to be way off your graph.
Told you. Yeah, but you didn't know that until she said that.
So I'm going to get negative 2 minus 8 plus 1, which is negative 9. So 1, negative 9 is another point. So I can use that and reflect it. And now I have a minimum of 5 points. Please do not make this look like a V shape. You could have plugged in negative 1, which nobody yelled out, or I might have done it. You could have plugged in negative 1. That would have been here. Please do not make this a V shape. It is a U. It's just a skinny U.
What's after the 8?
Oh, plus 1. I forgot to write the 1.
Where is that?
Okay, and while you're gone, we're going to start a new section.
Okay, so why did you plug in 1 for?
Oh, wait, we're going to
Why did
start
you
our
plug in 1 for X?
Because I just picked any X's that to find another point.
So you just said, okay, we're going.
Oh, I couldn't plug in 0 because I already had that answer. I couldn't plug in negative 2 because I already had that answer. So I just picked something near there, and I picked a
So
1.
you could just put any random number.
You can, but if you pick a really big number, it's not going to be on the graph. So I picked something near this graph,
Okay.
which is why I picked 1. Okay, at the bottom is just a review of all the stuff we've been talking about, just summarized again. We are going to take a quick brain break, and then we're going to do one more kind of graphing.
I
Okay?
can't
Get out of your seat, stretch your legs.
I can't not make it into a V. Like it always will.
This last form that we're learning about is written in intercept form. I skipped example 3. That's for a different day. And I went to graphing quadratic functions using x-intercepts. So intercept form looks something like this. A, and then we have 2 sets of parentheses. Inside of those parentheses, both the parentheses have an X. Now, in those parentheses, we could have a 0, we could have a number. It could be positive or it could be negative. So they just said minus P minus Q. They just used minus P and Q as just representing any numbers. Okay? So P and Q are just some numbers. P and Q are numbers. But they could also be 0. Just keep that in mind. They could be 0. Because that's what's going to confuse somebody when they go to their homework. It could be 0. even could be 0. No, like, yeah, it would just be an x by itself instead of an x minus or x plus something. Yes. Now, a is never 0 because this number out front, if that was 0, and it multiplied by everything, we'd have nothing. So a is never 0. But guess what? It's still called a. What does it tell us?
No vertical
Stretch or shrink, or
Yeah.
if there's a reflect in the x-axis. It's going to be the same for this too. So if a is a negative number, you know it's going face down. It's all the same. And then I'm going to go through these concepts. I'm going to go through these concepts as we do the example, but they're written down if you need to go back and look at them. So this is called intercept form because you can find the x really, really easily in this form. That's why it's called intercept form. It's the x-intercepts. So to find the intercepts, what you do is you're going to take each parenthesis, you're going to take each factor, and you're going to set it equal to 0. So you can set that first factor, which is negative 2, equal to 0. You're going to set x plus 3 equal to 0. And you're going to set x minus 1 equal to 0. You're going to set each factor equal to 0. And now we're going to solve for x in each factor. So in the first factor, how do I solve for x? I don't, because there's no x. This is just an a, so I don't need that one. But I'm doing that on purpose because someday you do need it. So I'm doing that on purpose. My next one, I solve for x. I subtract 3. So I get x equals negative 3. This one, how do I solve for x? I add 1. So I get x equals 1. So what is happening is we're saying if I plug in negative 3 right here, if I plug in negative 3, this is what's happening. Plus 3, what does that give me?
0.
So I have negative 2 times 0 times whatever. I plug in negative 3 here. It doesn't matter what it is. If I multiply 0 by the other two things, I get 0, which is at the x-axis, or on the x-axis. So right here, these are the x-intercepts. And we write those as ordered pairs. There's more than one, so I put them in fancy brackets. Oops, positive 1. Positive 1, 0. So I have negative 3, 0, positive 1, 0. I'm going to plot those on the graph. Now remember, we're going to make a parabola. And what does the parabola, what does the quadratic have right in the middle of it? Axis of symmetry. And you can see that's what I'm finding next. You can look at this graph and figure out the axis of symmetry because it has to be in the middle. What, negative 1?
0.
Nope. X equals negative 1. So to get this axis of symmetry, if we don't have a graph, to get it using like formulas, is you average the x-intercepts. So you take negative 3 plus 1 and you divide that by 2. If you find the middle of the two x-intercepts, that's going to be your axis of symmetry. So negative 3 plus 1 is negative 2 over 2 is negative 1. X equals negative 1 is our axis of symmetry. So if we know our axis of symmetry, how can we find our vertex? We know it's negative 1 comma something. That's right. That's right. How do we find the y part? You plug it in for x in the equation. Whoever said that somewhere over here, a lady. Yeah, you do f of negative 1. So in this equation, so we have negative 2 parenthesis, wherever I see an x, make it a negative 1. Wherever I see an x, make it a -1. It's got to be for both x's. So this form is different, but it's giving us all the same information. So I have -2 multiplied by 2 multiplied by -2, which is -8. Nope, +8. Just kidding. +8. So -1, +8. Does that make sense for my A value, which is negative? Is this going to be like a negative reflected graph?
Yes.
Do I have enough ordered pairs?
No.
So I have to pick something else. Oh, it's so much work. I have to pick something else. I'm thinking finding the y-intercept might be helpful.
Oh, maybe.
How do we find the y-intercept? We plug in 0. That's way easier than plugging in any other number. So I'm going to do f of 0. -2 times 0 plus 3 times 0 minus 1. So I get 6. And when I graph that, that makes sense. And I also have a point that it has a reflection point. Yes, Martin?
The positive 10 or wait, oh, okay,
Never mind, dear.
yeah.
Okay.
Any further thing?
Okay, let's try number 6. You're going to find your x-intercepts first. X-intercepts. To find the x-intercept, we take each factor and set it equal to 0. So my first factor is negative, which is a -1. My second factor is x plus 1. And my third factor is x plus 5.
Do we have to write down the first thing? Or is that
No,
just-
but somebody's going to get stuck when they go to do their homework because they don't do that. I'm just warning you ahead of time. You're going to be in XH asking me questions, if you try it before then. So I'm just trying to help you guys without having to be there the whole time. Okay, so that one won't give us an answer. I can cross that out. My middle x, I'm going to subtract 1 from both sides, and I get x equals -1. And then subtract 5, and I get x equals -5. So my x-intercepts I write as -1, 0, -5, 0. They are ordered pairs. You put them in parentheses. -1 and -5. Once you have those 2 points, we know they have to mirror each other. So we can find the mirror. Axis of symmetry.
So it's x equals -3.
So you can maybe look at the graph and find out it is x equals -3, or you can average the x values together. You can put -1 plus -5 divided by 2, average them, which gives you -6 over 2, which is -3.
Will it ever be like some fraction?
So if we average 2 numbers together, well, I shouldn't say that. As long as these are integers, if we average 2 numbers together, the only fraction would be like 0.5. Other than that, if I give you horrible numbers, which I didn't give you horrible numbers, then you might have yucky answers, but
Is this our homework?
it's going to be graphing. Okay, just like the 3 different kinds. Okay, and then, vertex, how do we find our vertex? F of, we put in our vertex -3, so we do negative parenthesis, -3 plus 1, -3 plus 5. So I get -2, 2. +4. Oh. So I got my vertex. at negative 3, 4. And that looks like the graph is going to open down. Is that true?
Yeah.
Okay. What is another thing that I could find that would be helpful? I think my y-intercept I could find by doing f of 0, plugging in 0. So we get negative, then we have 0 plus 1 and 0 plus 5. Negative 1 times 5. Negative 5. Oh, and then Devin said something like, I think it was Devin, said something like, oh, is it up 1, then up 3, then up 5? You guys remember that pattern? So if there's no stretch, that pattern is true. So you could even figure out these points. Once you found the vertex, you could figure out these points by doing that 1, 3, 5 thing. Because there's no stretch on that one. All right, last one, and then I'll give you your assignment. So this, it will be posted. So the last one, same thing again. How do we find our x-intercepts? Right, we said everything equals 0, so 1/4 equals 0. I'm not going to be able to use that one. X minus 6 equals 0, so x equals 6. We add 6 to both sides. And then x minus 2 equals 0, add 2 to both sides, and I get x equals 2. So our x-intercepts are 0, 6, and 0, 2. No, they're not. No, they're not. They're 6, 0. I just wrote them in the wrong order. 2, 0. Right, and then I think, and that's the wrong order. I think, then right. I'll look at my graph. What can I find? That's right in the middle. So x is 4. Good. Or you can average together. 2 plus 6 is 8. Divide by 2, 4. Vertex. Now we're going to do 1/4. So you're going to do f of 4. Oh, g of 4. Sorry, this is g. G of 4. You're going to do 4 minus 6 and 4 minus 2. So I have 1/4 of negative 2 times 2. Now remember, when you multiply, you can multiply in any order that you want. So I'm going to do 1/4, and I'm going to multiply the 2 and negative 2 first, so I get negative 4. And what happens when I multiply together 1/4 and 4, negative 4 over 1? I get negative 1. So my vertex is at 4, negative 1. And what's another point we could find? So we'll do g of 0. So 1/4 times negative 6 times negative 2. 1/4 of 12 is 3. 0, 3. So make sure it is spaced the same on both sides of the axis of symmetry, because I messed that up at first. Yep. So all of your homework is going to be graphing, and it's sectioned off. Like, it's not like you have to figure out which method to use. It's going to be, the first ones are all vertex form, the second ones are all standard form, and the third ones are all this form. Okay? And I have graph paper provided for you. It is a book assignment. So remember, we went over how to get on the book online. And you could always screenshot it if you